Most real-world projects are going to include some kind of data persistence. In this demo, we're going to take a look at how to connect to and work with relational databases using the clojure.java.jdbc library, which provides low-level JDBC access to SQL databases. Being low-level means that the abstraction layer is pretty thin, and we're often going to be writing parameterized SQL or raw SQL as arguments for our forms and functions. Typically, you want to use a higher level DSL to work with a database, but most of the libraries for doing so are actually written on top of clojure.java.jdbc anyway, so it's definitely worth knowing. We're going to be using Postgres, but the same principles would apply to MySQL, SQLite, SQL Server, etc. As far as prereqs, to follow along, all you're going to need are Postgres and Lineagen installed in your machine. Instructions to do so are on each of the respective sites, and it's going to vary by operating system, but either way, it's pretty straightforward. So we're building a public land finding application, and what it is an app to help hikers, bikers, and backpackers find public land to explore. So state forests, national forests, BLM land, that kind of thing. But we're at a really early stage in the development, and we're not sure which SQL library we want to work with. And we know there's going to be a database, but we don't know how to connect to it. So this video is mostly going to be in the REPL, and we are going to be pretty much just examining clojure.java.jdbc. We'll do some other videos in the series where we'll look at some of the other ones, some higher level DSL libraries, as part of our evaluation process. The first iteration of this app is going to just look at state forests for now. And so this is our very basic ERD. We have a state table and a state forest table. State table has a state ID as the primary key, which is just serial integer. State is the name of the state, and abbreviation, or ABRV, is the two-letter abbreviation for that state. State forest has a foreign key that points back to the state table's primary key. And state forest ID, again, serial. State forest is the name, and acres is the size. But with that gone over, we can go ahead and start setting up roles and for the database. So let's hop over to the terminal. I've got pSQL open. So we are going to create user. We'll call our app user public land user with a password of keep public lands in public hands. Words to live by. All right, so we've got our role created. So let's create our database. Database, and we'll call this public land. We want the owner to be public land user. All right, we've got our database. So let's just connect to it, make sure everything worked out properly. Cool, and now it should be empty, right. So empty database, ready to go. Okay, so the next thing is to create a new line project. So we're just going to create a new app. So we'll say line new app, and we're going to call this public land user. Okay, we'll cd into the public land user, run tree. All right, so standard app structure. So for this demo, like I said, we're going to be working in the REPL. Now, working in the standard Clojure REPL, it's fine, it's not bad. But for extended sessions, or sessions where you want a record of the entire session so you can reload it, replay it whenever you want, I like to use Gorilla. And there's a plugin called Line Gorilla that will add a convenience command to launch it from Lineagen. So let's go ahead and, so I like to create a WS directory. So do this, now we'll run tree, and you can see now I've got my new WS directory right here, and what this is for are Gorilla worksheets. So the session in Gorilla can then be saved out to a worksheet file in this directory. So this is a pretty standard thing I do for all my projects. All right, so with that done, let's go ahead and open up Vim and edit our project.clj. All right, so the first thing we'll do is start with our dependencies. Now if we go back to the web, we'll just close that one out. So the first thing we're going to bring in is clojure.java.jdbc. All right, so here's our dependency info. So I guess the stable release is alpha 1. Seeing alpha in the name is a little nerve-wracking, but we'll go with it. So there's that. If we go back over here, you can see that it says we're also going to need the dependency for the JDBC driver we want to use. So it includes a central link for PostgreSQL. So let's go ahead and click this. We're going to hop over here. And these are all the different versions. Now we want the latest version, and we're running Java 8 on my machine, so we're just going to grab the standard version. So we'll grab our line again, dependency info, hop back over to Vim, and paste it in. Awesome. All right. So we have all our dependencies. Now, I mentioned that we wanted to use the Line Gorilla plugin, so let's go ahead and add a new section for plugins. And we want to bring in Line Gorilla, and I think the latest version is 0.4.0. And that should do us. Quit out of this. Now if we run Line Gorilla. So the thing to pay attention to here is the URI for where it's running. So I'm going to copy that. So now if I go over here, all right, if you haven't used Gorilla before, they've got a pretty good website with some awesome videos that go over how to use it. And I recommend doing that because we'll have other videos that go in depth in Gorilla, but this isn't one of them. So the first thing I'll do is just change the title. Let's see, public land finder. And the description will be, the session is to evaluate the clojure.java.jdbc library for database access. All right, good enough. So let's change the namespace to whatever we want. I'm just going to call this public land finder. Cool, and now we can do our requirements. So the first thing we're going to want to do is bring in clojure.java.jdbc. So clojure.java.jdbc, and let's see, we are going to do, let's alias that to J so we don't have to type that out every time. Now the other thing I want to do is alias clojure.string as str because we're going to use that a couple times in this series, and it'll just make it significantly easier to just write str instead of the full library. All right, so the first thing we're going to need, if we go back to this home page, you can see that they've got these DB specs, and this is basically the connection information for a database. You can also use this connection URI if you want to use a connection string, which you might be more familiar with. But I am going to also pull up the doc for this so you can see what that looks like as well. So here's DB spec. Okay. So we don't need all of these connection settings. So I'm just going to enter the bare minimum for what we want to do. All right, so we'll call our spec object DB, and we'll add a, let's see, so first we need a DB type, PostgreSQL, DB name of public land, and then if we have the host, localhost, which might be default, but I'm going to add it anyway. User is public land user. And finally, password is keep public land in public hands. Cool. All right, so there's our spec object. So the first form that we're going to use is the create table DDL. So this guy. So the way this works is it takes the table name as a keyword, and then couple parameter groups of entities, and the entities basically describe a column name and sort of whatever parameters you need to set it up. So that'll make more sense when in practice. So let's just go ahead and create a SQL string object. So the state SQL would use the create table DDL form. We're going to pass in table name, state, and then we do our entities. So we'll do state ID, and let's just pull the ERD back up. So you can see we've got state ID, which is serial and a primary key. And what that will look like is state ID. We'll tell it's a serial data type, and then we'll pass, tell it's a primary key. So that'll build a primary key constraint. So next we'll do the state, which is the name. This is varchar 32. And finally, we need the ABRV column, and that is varchar 2. All right, boom, boom, boom. So we've got those two, these two. Okay, so that's our SQL. So let's check a look at what it built for us. Println state SQL. All right, here we go. So this is the raw SQL. If I copy this and hop back over to pSQL, I can paste that right in there and run it. And now I've got my state table all created from state. Yeah, it's empty, but it's there. So let's actually do that through Clojure though. So we're gonna drop table state. Yeah, DT, right. So hop back over to Gorilla. And let's see, so we've got our state SQL. So now we're going to use our first form, which is the execute. Let's hop back up here, the execute. And so what this does is it basically takes a database and it takes SQL parameters. And you can see that it also takes this multi option. We'll get into multi inserts later, but for now, just remember that that exists because the forms are very similar. Okay. So let's insert this. So we'll say j execute bang, the DB spec, and then we're going to pass in the state SQL. All right. So now if we go back to here, we'll say select all from state, and you can see our state table is back. All right. So our state table exists. Let's add a row to it. And so to do this, we're going to be using the insert form, and this it's pretty similar to the execute form. So it takes the database spec, it takes the name of the table, and then it takes a map of the values that you're going to be inserting. So for us, we were going to say j, and we'll insert these states in alphabetical order. So insert to our DB into the state table, and I want to insert Alabama, which has an abbreviation of AL. Boom, boom. Right, there we go. So what insert function will return is going to vary by database. I think MySQL returns just a sequence with a number of records that were updated, but Postgres actually for insert returns the entire row. So this is the new row that was created from the successful insert statement. So this will be less interesting because of how it returns, but we can run our first query against the database, and we want to, let's see, select everything from state where state equals, and this is a parameterized SQL statement. So this question mark gets substituted for whatever immediately follows it. So Alabama, and there we go. Like I said, not very exciting because that's what it returned up here anyway. So let's do something a little bit more exciting. Let's add some more rows, make this interesting. So the form we're going to use to do that is insert multi. Now insert multi takes the data, similar to insert, takes the database spec, it takes the table name, and then it takes, instead of a single map, it takes a collection of hash maps before it does the insert. And so let's see, so what that looks like is insert multi, DB, we're going to go into state, let's see, the next one in alphabetical order is Alaska, the abbreviation for which is AK. Then we need our Arizona, the abbreviation for that is AZ. And finally, the state is Arkansas, and the abbreviation is AR. Everything's closed. Okay, so there we go. We've inserted our 3 new states. You can see that the serial primary key is incrementing properly. Yeah, we're good. So the other way you can insert multiple statements is through the db_do_prepared form. So that looks like db_do_prepared. This is a prepared statement form. So into our database, what we're going to do is we are going to insert into state, and then we want to pass in the state and the abbreviation, and then the values will be parameterized. So question mark, comma, question mark. All the other elements in this vector are going to be parameter groups that match up with this format, so state and abbreviation. So we want California CA, we want Colorado CO, and we want Connecticut. And to make things interesting, we are going to completely mess up the abbreviation for Connecticut. So you'll see why in a second. And then we need to tell it that it is a multiple insert. So multi question mark equals true. Okay, so instead of returning the row results, this one actually returns a list of the different updates. So we updated 3 records. Well, and the update is added in this case, but we've added these 3 new records, and that's why we get this back. Cool, all right, so let's fix our erroneous abbreviation for Connecticut. So we hop in here, let's get some space. For that, we're gonna use the update bang form, update DB, we're gonna be updating the state table. We want the new value of abbreviation to be Connecticut, and our query is where abbreviation equals, and the parameter would be XX. That's it. Right. So you see it returns that it updated 1 record, which is what we were hoping for. So now just to be sure, let's run a query on that. jQuery DB, and we would like to select ABRV. Oh, let's just select everything. Select everything from state where state equals Connecticut. All right, here we go. All better. All right then. So what we're getting back here are result sets. So this is just a single value result set. Something like up here, if we were to just run, let's see, if we just want to grab this, no, let's grab the whole thing. We'll just pull back all the states this time. So select all from state. We don't need any parameters, so let's get rid of this. Run that. This is a result set. Now, we can do different kind of processing on this result set. So there's 2 different ways we can do it. We can use the result set function or the row function options. And you can think of result set function almost like a reduce statement where it performs some function against the entire result set, whereas the row function is more like map, where it'll apply whatever function you pass in there to every single element in the collection, in the result set collection. So let's illustrate that. So the first one we'll use is the result set function. So that same query, let's see, or same-ish query, so let's copy that. Only this time what we'll do is we will say result set function, and we're going to pass in the clojure.core count function, which simply counts how many elements are in a list. If we run that, we get 7. All right, so then, like I was saying, we can also use the row function. Now, if you look at each of these elements that it's returning is a hash map. So if you've worked with Clojure, which I assume you have if you're following this video, you know that if I were to say something like, if we use state ID, this keyword is the name of the function, and we pass in one of these guys as the value, if I run this, I'm going to get 1 back. Okay, so keep that in mind. So we're treating the keyword as the function, and then the map is the argument that's being passed in. So if we wanted to get back a result set that just had, let's say, all the abbreviations, we could use the row function to do so. So what that would look like is let me grab this, copy it, paste it, and we would want to pass in results. So we will actually want to use row function, and we want to pass in ABRV. So now if I run this, I'm just getting back the abbreviations, right? So like that would have been equivalent to up here. Probably makes more sense. There we go. Okay. So we can also combine these. We can combine result set function and row function and use them at the same time. So let's say I want a function to quickly retrieve the state ID for a state if I pass in the name or the abbreviation. So what we can do is we will write a function called ID for state. It will accept a string, and it will have a condition where if the length of the string is 2, it can assume that it's working with a state abbreviation, and it will select state ID from state where abbreviation equals parameter for s. Now, what we want to do is we want a row function to grab state ID, and we want a result set function. Well, here, let me show you. So if I just ran this by itself, let's see. So let's see this. I will run it by itself so you can see exactly what we're getting before we add in the second. And this would be, so if it's not 2, it's going to be state. Is that correct? I think that's correct. Yeah. All right, so now let's put this back up here. So if I create this, so let's test it. So if I say ID for state, let's say CA. All right, so you can see though what it's returning is a list. And I don't really want the list. Like all I want is a scalar value with the ID. I don't want to have to mess around and like clean that up later. So what I'll do is result set function, and I just want the first value. Same thing down here. Result set function first. All right, we'll rebuild that. And now if I run this, it's just going to return the ID value. So let's see if it works for full state name. And that will not work because it is completely wrong for state. All right, cool. So we're good.